Two photographs of the same patch of sky, taken weeks apart in the early 1950s. In the first, a point of light. In the second, nothing at all. Astronomers have now found more than 100,000 of these, and after 6 years of argument, they still can't agree on what they are. Here's the part that makes this hard. Every explanation offered so far runs into the same wall, and that wall is a question you can ask about any photograph ever taken. Imagine you photograph the night sky through a window. A bright dot appears in the picture. Is it a star, or is it a speck of dust on the glass? From the ground, from the image alone, those two things look identical. Everything in this story is that question, asked about 100,000 dots on glass plates that were exposed before anyone alive could check. Between 1949 and 1957, the Palomar Observatory in California photographed the entire northern sky. The instrument was the 48-inch Samuel Oschin Smith telescope, and the medium was glass, not digital sensors. Glass plates coated in light-sensitive emulsion, each one exposed for up to 50 minutes. The survey was called POS-1, and it was never meant to catch anything that moved or changed. It was a static map, a catalog of what's up there, for astronomers who wanted to know where things are. It helps to understand what comparing these plates actually involves. You take a photograph made in 1952, find the same patch of sky in a modern digital survey, line the two up star by star until they match, and then look for anything present in one and absent in the other. Do it once, and it is an afternoon. Do it across the whole northern sky, and it is a decade of work for a team and a lot of software. Which is exactly why it is now the most interesting archive in astronomy, because it recorded the sky during a window that can never be reopened. The first artificial satellite, Sputnik, launched in October 1957. Almost every plate in the survey was exposed before that. There was nothing in orbit, not one object. Whatever those plates caught, it was not a satellite because satellites didn't exist. In 2019, a team led by Beatrice Viroel, an astronomer at Nordica in Stockholm, started a project with a strange goal. They wanted to find a star that had simply disappeared. Sounds like a fantasy, but there is real physics behind it. A massive star can, in theory, collapse straight into a black hole without exploding first. No supernova, no flash. The star is there, and then the star is not there. If that happens, the only way to catch it is to compare an old photograph with a new one. The project was named VASCO for vanishing and appearing sources during a century of observations. They compared the old plates against modern digital surveys, and they did it at scale, 600 million sources. And here is the result, stated plainly because it's the part that almost never gets reported. They found nothing. Across 600 million objects, not one genuine vanishing star was identified. The video you've seen about this story probably didn't tell you that. It's the most important sentence in the entire field. What the archive kept producing was something else. Points of light that appear on one exposure in one place and never appear again. Not before, not after, not in any modern survey. Astronomers call them transients. The counts are large. A published catalog lists 5,399 candidate vanishing sources from the POS-I plates. A later analysis of the same archived work with 107,875 transient detections, spread across 2,718 observing nights. And some of them are not lonely dots. On one red plate from April 1950, 9 point sources appear together, all at once, in a single exposure, and none of them is there in any other image. Another case from July 1952 shows 3 bright transients in a line. It's worth being precise about what a transient is and is not. It's not a star that faded. It's not an object that moved, because a moving object on a 15-minute exposure draws a line, not a dot. It's not a known asteroid or a known variable star, because those were checked and removed. It's a single point of light present for one exposure, absent in every image taken before and since. including the ones taken with instruments that would see it easily if it were still shining. And they are faint. These are not blazing objects. Most sit near the limit of what the plates could record at all, which is part of why the argument is so hard to close. Everything near the detection limit of any instrument is contested, always in every field. A single dot on a photographic plate is a shrug. 9 of them appearing and vanishing together in one 50-minute window is a question. If you want to see how this argument actually resolves and what the skeptics have that the believers do not, subscribe and turn on the bell. The next part is where the evidence starts fighting itself. This is the mainstream explanation, and it deserves to be taken seriously because it is almost certainly true for a large fraction of these dots. Photographic emulsion is imperfect. It has flaws, bubbles, scratches. The plates were handled by hand, stored for 70 years, and later scanned. Any of that can put a small round mark on the glass that looks exactly like a faint star. This is not a fringe objection. It is what most astronomers assumed from the beginning. There is a second layer to the same objection. These plates were not read by eye. They were scanned decades later, and every scan introduces its own artifacts. Dust on the scanner is indistinguishable from dust on the plate, which is indistinguishable from a star. The chain from the 1950s sky to a number in a modern catalog passes through a lot of hands and a lot of glass. Viruel and her team argue back with the shape of the dots. On a 50-minute exposure, a real star is never a perfect point. The atmosphere blurs it. The telescope drifts a little as it tracks, and the result is a slightly soft, slightly smeared disk. A flash that lasts a fraction of a second gets none of that blur. It hits the plate and it's gone before the atmosphere or the tracking can smear it. So, counterintuitively, a genuine sub-second flash should look sharper and rounder than a real star. That's the argument. Some of these dots are too sharp to be stars, and their sharpness is evidence they were real light arriving fast. And this is where the field splits. Other researchers look at the same narrow, round profiles and say the opposite. That roundness is exactly what an emulsion flaw looks like. Same data, opposite conclusion. A bright object that flares once and never returns is a very good description of sunlight glinting off a tumbling piece of metal in orbit. Modern sky surveys deal with this constantly. Satellite trails are the plague of contemporary astronomy. But the dates close this door. Sputnik went up in October of 1957. Almost every one of these plates was exposed before that, some of them 7 years before. There was no hardware in orbit to glint. This is the strongest single fact in the entire story, and it is also the reason the story refuses to die. Whatever is on these plates, human satellites are not on the list of suspects, which leaves two families of explanation. Either the marks are on the glass, or something was up there that we did not put there. There is one measurement that can tell those two families apart, and it's beautifully simple. Go back to the window. If a dot is a speck of dust on the glass, it does not care where the Earth casts its shadow. Dust is not lit by the sun, it's just dust. But if a dot is a real object in orbit reflecting sunlight, then it must go dark when it passes into Earth's shadow. Every satellite does this. It's not a theory, it's geometry. So the team mapped where the transients fall relative to Earth's shadow cone, out at geosynchronous altitude, about 26,000 miles up. And they report a deficit. Fewer transients inside the shadow than outside it. The number that matters here is the altitude. Geosynchronous orbit is roughly 26,000 miles above the surface, a tenth of the way to the moon. That's where the shadow analysis places the constraint, and it is a strange place for anything to be in 1950 because nothing human reached it until the 1960s. If that result holds, it's very hard to explain with dust because dust has no reason to avoid a region of sky defined by where sunlight can't reach. It's the kind of test that could eventually settle this, and it's the reason serious astronomers are still looking. In October 2025, the story got stranger, and the strangeness cuts in two directions at once. A study published in Scientific Reports examined 2,718 observing nights against 124 days on which above-ground nuclear weapons were tested. It reported that transient detections were significantly elevated within 1 day of a nuclear test. The relative risk came out at 1.45, with a probability of about 0.008 that the pattern is chance. That is the finding. Now watch what happens to it depending on who's holding it. If you already believe something was watching us, this is the headline of the century. We set off atomic bombs, and things showed up over the next day. If you are a skeptic, this is the moment the mundane explanation finally arrives. Above-ground nuclear tests put radioactive particles into the air across North America. Radioactive particles land on things, including boxes of photographic plates in California, and they fog the emulsion. The correlation is not evidence of visitors, it is evidence of fallout. Villarroel has an answer to that too. Fallout contamination, she argues, produces diffuse fog patches, not the discrete point-like profiles these transients show. Different damage, different fingerprint. So here is the honest state of it. The single most dramatic correlation in this field is also the single strongest argument that the whole thing is contamination. It's the same number, it just depends which way you read it. There is one date in this archive that everyone eventually arrives at, and it's worth telling straight before we take it apart. In the summer of 1952, the United States was in the middle of the largest wave of unidentified object reports in its history. On 2 consecutive weekends in July, objects were tracked on radar at 2 airports around Washington, reported by airline pilots in the air and witnesses on the ground, and fighters were scrambled. On the 29th of July, the Air Force held what was then the largest press conference the country had ever seen. Major General John Samford stood up and said that the reports came from credible observers describing relatively incredible things, and that the Air Force could find no pattern in them. 70 years later, working through the Palomar plates with automated software and no interest whatsoever in that history, the Vasco team logged transients on dates from that same July. They weren't looking for it. By their own account, the connection was noticed afterwards when someone went back and read the dates. That is a genuinely arresting coincidence, and it is the reason this story travels. It's also the exact point where a careful video has to slow down instead of speeding up. Now the part that most coverage of this story skips. None of this is evidence of alien spacecraft. Not the 9 dots, not the shadow deficit, not the nuclear correlation. What the data shows is that a large number of unexplained marks exist on a set of old glass plates, and that the community cannot yet agree on their origin. There is a real temptation here, and it's worth naming. Some of these transients line up with famous UFO reports from the summer of 1952, including the 2 weekends when objects were tracked over Washington. That coincidence is genuinely striking, and it is also exactly the kind of coincidence that human beings are worst at evaluating. With 100,000 events spread over 8 years, some of them will land on famous dates. That's not a conspiracy, that is arithmetic. The alignment is worth checking, and checking is a job for statisticians, not for anyone who already knows the answer. There's also a straightforward reason to accept coincidences in this direction specifically. 1952 was a peak year for public reports of unidentified objects, which means it was a year when a lot of people were looking up and writing things down. Any archive of unexplained events will overlap with any other archive of unexplained events if both of them happen to be busy in the same summer. Villarroel herself does not claim these are alien probes. She treats it as an open hypothesis among several, and she has taken a remarkable amount of abuse for saying even that much. The frustrating truth is that a 70-year-old photographic plate can probably never settle this on its own. Every argument about it is an argument about damaged glass. What would settle it is catching one now. If these flashes are real objects reflecting sunlight above the atmosphere, they're still up there, and modern instruments should be able to see them. That means multiple telescopes separated by enough distance to measure parallax, watching the same sky at the same instant. If 2 telescopes hundreds of miles apart see the same flash at the same moment from slightly different angles, The geometry gives you a distance, and the argument ends that night. There's a second test, and it is even more direct. If one of these objects is still in orbit and still reflecting sunlight, then a modern telescope pointed at the right place should be able to catch a flash and measure its spectrum. Sunlight bouncing off metal has a signature. It's not the same as a star, and it's not the same as a flaw in glass. One clean spectrum would end 70 years of argument in an afternoon. That work's starting, which means this is not a story about 1952. It's a story about an experiment that is being set up right now, and about a question that could be closed within a few years in either direction. Go back to the window one last time. A dot on the glass and a light in the sky look the same in the photograph. The entire history of astronomy is the history of learning to tell those two things apart, and every time we invent a way to do it, we find that some of what we thought was dust was real, and some of what we thought was real was dust. 100,000 marks are sitting in an archive in California, made before anything human was in orbit. Some of them are almost certainly flaws. Some of them may not be. Nobody has been able to sort them yet. That's not a disappointing answer. That's what an open problem looks like from the inside before anyone knows how it ends. And if you want the other side of this question, the one about how hard we have actually looked for anything out there, we made a whole video on it. The short version is that in 60 years of searching, we have covered about the size of a coin on a table the size of the galaxy. Start there.